Namaskara. Today's topic is CKP sensor, that is Crankshaft Position Sensor. The main responsibility of this sensor is to determine speed and the position of the crankshaft. Few questions come to our mind, such as what is the need to measure the speed of the engine? Why do we need to know the position of the crankshaft? What is crankshaft? First, let's understand what is crankshaft. Crankshaft is a mechanical component which converts the linear motion of the piston to a rotational motion. Give me few seconds, I'll bring my whiteboard for detailed explanation.
A few moments later.
Now let's understand this diagram. Here, for example, I have taken 3-cylinder IC engine with fuel injectors. This is a crankshaft. This is a crankshaft position sensor and it is connected to ECU, and ECU is controlling fuel injectors. Here in this diagram you can see cross section of an engine. This is a cylinder wall, this is piston, this is crankshaft, and piston and crankshaft are connected by connecting rod. As I mentioned earlier, the up down motion of the piston, that is linear motion of the piston, is converted into a rotational motion by the crankshaft. Now the topmost part of the cylinder is called TDC, that is top dead center, and the bottommost part of the cylinder is called BDC, that is bottom dead center. First, let's understand what is the need of crankshaft position sensor, that is why is it important to know the crankshaft position. As we all know, in an IC engine, combustion happens over 4 cycles. They are intake cycle, compression cycle, combustion cycle and exhaust cycle. Usually at the end of the compression cycle, that is when the piston is coming from BDC to TDC and compressing the air, the fuel is sprayed from the top. That is when air fuel mixture is combined and a spark initiated by the spark plug leads to combustion. That's why it is necessary for the ECU to know at what time the piston reaches the top dead center to control the fuel injectors. It also takes the input from the camshaft position sensor. This helps in synchronization and to know if the cylinder has entered into compression cycle or not. Now let's understand this diagram. If you observe here, the inner part is the crankshaft and the outer part is timing rotor or timing gear. It is often referred as sensor ring as well. And this is crankshaft position sensor. This timing rotor will be mounted onto crankshaft, and if you observe, it has few gear teeth on them, and in this part there are missing gears. This is intentional in the design to recognize the TDC part. Here in CKP sensor we can see 3 wires, that is first one is power, usually it will be 12 volts, second one is reference, that is 0 volts, and the third one is signal output, usually it will be in the range of 0 to 5 volts. Let's understand how exactly this sensor works. Imagine the crankshaft is rotating clockwise, thus timing rotor will also be rotating clockwise. As soon as this teeth reaches in front of this sensor, a voltage will be induced. That is, you can observe here, this is the first tooth's voltage, a spike is there and a drop, and as soon as the next teeth reaches, one more spike is there. Similarly, for all the teeth we are getting a spike, and when we get a gap or missing teeth, there will be no voltage produced, and again voltage starts and no voltage produced. This signal is a raw input from the sensor, that is it is in analog voltage. First this will be converted into digital signal using a converter called ADC, that is analog to digital converter, and this will be present inside the sensor itself. This converts the analog signal into digital signal, that is it is in the form of PWM signal. Here what you can observe is, as the teeth comes in front of the sensor, there is a square wave generated, and similarly for every teeth, and for the missing teeth there is no voltage generated here, and similarly here we have voltages and no voltages. What this is representing is, when there is no voltage generated, the piston is in the TDC. That is, as soon as there is no voltage or a missing teeth is detected, ECU will get to know the cylinder has reached the TDC. By cross-referencing this waveform with the camshaft position sensor, ECU will understand if this piston is in the compression cycle, and thus ECU will control the particular fuel injector of this cylinder to spray the fuel. Also, one more thing I want to point out, you might have heard about timing chain. Timing chain is connected between crankshaft pulley and the camshaft pulley. This helps in synchronizing the opening and closing of the valves with the crankshaft. Now let's learn what are the types of CKP sensor. The first one is Hall effect type. This sensor internally contains a magnet and Hall effect element which produces a voltage when it detects a changing magnetic field. That is, whenever a tooth comes in front of a Hall effect type sensor, a voltage is generated. That voltage will be converted to PWM using ADCs. This sensor needs an external power, usually 12 volts and ground. Another wire is signal output. The second one is inductive type. This sensor uses the electromagnetic induction to generate the voltage. That is, it consists of a permanent magnet. A coil is wound around that magnet. As soon as this gear comes in front of the inductive type, due to the changing magnetic field, a voltage will be induced in the coil. That is electromagnetic induction. Similar to Hall effect type, the voltage output will be in the analog type that will be later converted to PWM using digitizers. This sensor doesn't need external power. Usually will have only two wires, that is, one is reference ground and another one is signal output. The third one is optical type. This will have a transmitter and receiver. Usually this timing rotor will be solid with the single slot in it. TX will be sending a light or laser. As soon as it passes through a slot, the RX receives the input signal. Now let's understand why do these sensors fail. Over a period of time, on the sensing part of the sensor, there might be a layer or a film of dust, oil, grime or grease deposit which might prevent the sensing altogether, or it might give an intermittent signal to ECU, or there might be a situation the issue might be on the wiring harness side. That is, either a wire is damaged or either this power can be shorted to ground or this ground may be shorted to power, or there can be even situations where the signal wire may be short to ground or short to VCC. Thus, the ECU will not get the input of CKP sensor. Now let's understand the symptoms of faulty CKP sensor. First one is MIL, that is malfunction indication lamp or check engine light. This will come on as soon as the ECU detects some fault in this system, and CKP related codes are always permanent, that is, which cannot be cleared without solving the problem. That is, even if you clear these fault codes without solving the issue, it will come back again in the next cranking cycle. That's why it is necessary for you to fix the issue, then clear the codes. And the second one is engine won't start. That is, if there is any issue with the crankshaft position sensor, the engine will never turn on, no matter how many times you crank. Or even if you give starter fluid or if you give petrol into intake system, it will not start. That is because ECU is fundamentally dependent on CKP sensor for fuel injection purposes. That is, if there is issue with the CKP sensor, ECU will not control the fuel injectors. Thus, the engine will not start. And the next one is misfire and poor performance. If the CKP sensor is faulty, then the ECU will not know if the cylinder has reached the TDC. Thus, it will not inject fuel into that sensor. Thus, it will lead to misfires. If the CKP related faults come on your vehicle, you should never ignore it, because if a permanent error gets registered in the ECU while you are traveling, the car will suddenly stall and it will never start back. That is, you have to tow your vehicle to the nearest service center. I hope you understood my explanation of CKP sensor, and if you learned something or you found this video to be informative, please do like, subscribe. In future, I'll try to make practical videos using multimeter and oscilloscope. I'll show you the waveforms of the CKP, CMP and other sensors. That time you will be able to correlate what you have learnt in this video. Until then, bye bye.